Okay, so let's get started. Yesterday we were discussing, let's see if this thing is recording. Okay, yes, I think it is. Just double check. I think I can read well that it is. Guys, yeah, okay, great. So yesterday we did power series and Taylor series. We did Taylor and Maclaurin series. So let's do some examples. I will restart one of the examples that we did yesterday because I don't think it was captured. Find the Taylor series of f of x equals sin x around a equals 5. Okay, so how did we start this? Guys, everybody, I appreciate. Yeah, okay. So how did we approach this problem? How did we start it? We did the same one yesterday. How did we yesterday? Very good, thank you. Great, and then what do I do? Yes. I use the trig identity. What identity is it? Sin A plus B is sin A cos B plus sin B cos A, right? So let's see. This is sin pi over 3 cos x minus pi over 3 plus cos pi over 3 sin x minus pi over 3. And then what do I use? How do I find the power series expansion? How do I find the power series expansion? Yes, sir?
You can simplify the sin pi over 3 and just use the identity for both side and side.
So sin pi over 3, so what is it? Square root over 2.
Root 3 over 2.
Okay, and what do I do with the cos pi over 3? I should remember that cosine of A is equal to what? Sum n equal to 0 to plus infinity minus 1 to the n. A to the 2n plus over 2n factorial. And sine of A is equal to what?
Instead of 2n, it's 2n plus 1.
Awesome, very good. And this works for any real number A, right? This belongs for A and R. So let me just apply this. Now if I replace my A by x minus pi over 3, I get a series around pi over 3, right? Well, I think A is bad here. Let's say Z. Well, I mean Z is worse, but let's put Z. But I mean Z is not very unnatural, actually. But it's Z. Z is it. Well, it's not worse. This is this. Anyways. So what is x minus pi over 3? What is the cosine of? Is that minus 1 to the n x minus pi over 3 to the 2n over 2n factorial plus what? 1 half okay, that's what we did yesterday. Is that clear or not? Okay, shall we do one more? A few more? Let's do something. We did it yesterday, but yeah. No question? Okay. Don't hesitate to ask. Okay. Great. Let's do one more. What do you want to do? We did yesterday sine squared x, right? we did sine squared x. So let's redo sine squared x and do cos squared x at the same time. Okay? Which one do you want to do? Or both? We do both or one of them? Well, find the Taylor series of f of x is equal, let's say, cos squared x around a is equal to 0, and find, someone give me an even number. Who wants to give me their favorite even? Higher, a bit higher.
A.
Sure, A. Fine. Okay. So yesterday we did sine squared x. So now I'll do cos squared x. It's kind of the same idea. What do I want to do? Someone else? Yes, sir?
Use the half angle formula.
I use the half angle formula. So what does it say? It states, the half angle formula states that cos squared x is equal to
1/2 plus cosine, minus cosine 2x.
So 1/2 plus plus. Yeah, so always remember something. How do you remember these? Do you know the formula for cosine 2a or not? So what is cosine 2a? It's 2 cos squared a minus 1. You know this or not? Do you know what cosine a plus b is? Do you have this formula memorized? So it's cos a cos b minus sine a sine b. Start from here. Do you know how to rederive these things, or you just used to memorize them? You just used to memorize them? Do you want me to tell you how to derive it? Or, I mean, you should memorize this. Cos A plus B. This is just cos A plus B minus sine A sine B. Right? Agreed? Yes, this you have to know. I mean, this you can rederive as well, but. Now what do you do? Plug in B equals A, you get cosine 2A. It's cos squared A minus sine squared B. Right? Yeah? Great. So what is sine squared in terms of cos squared? 1 minus cos squared, right? This is cos squared A. Cos squared A minus 1 minus cos squared A. Great. Boom. So you get 2 cos squared A minus 1. Right? Now you want cos squared A in terms of cos 2A. Take the one on the other side and divide by 2. Okay? And you can do the same for, you can do the same for sine 2A, I guess. Sorry, for sine squared A. Work, okay? If you want sine squared A, what do you replace? You replace the cos squared by 1 minus sine squared. Right? You get 1 minus 2 sine squared A. And then you bring it on the other side. You get sine squared A is 1 minus cosine 2A over 2. Okay, is it clear? Did you see these before? You saw how to rederive these? This is how you rederive it. Okay, that should be fairly simple. Again, I wouldn't bet on memorizing. It's good to know how to derive things rather than memorizing, because one mistake and it all goes away. Okay? Especially in multiple choice questions. Great, so what do I do now? What do I do now? How do I find the power series around A equals 0? We did this yesterday. What did we do yesterday? Yeah, you want? Yeah.
Use the identity cosine.
Cosine of z, cosine of something is equal to this thing, right? So I get 1/2 times 1 plus, what is this? Sum n equals 0 to plus infinity, minus 1 to the n. What is that then? 2x to the 2 2n over 2n factorial. Right? Let me just, yeah. Sure. Now, how do I simplify? I just have to incorporate the 1/2. What is the constant term here, by the way? So if you plug in x equals 0, what do you get here? 1, right? Take n to the 0, what do you get? So let's write this, let's rewrite this. This is a bit more interesting than the other one. This is 1/2 plus 1/2 minus 1 to the n, 2x to the 2n over 2n factorial. Right? Then how do you get the x alone, the x and the constant term? What is the constant term of this? What is the first term of this one? Yeah.
Not distribute the powers for 2 and then for x.
So, yeah, sure. Okay, yeah. You want to do this? Sure. But I wanted to say, like, what is the constant term of this one? What is the coefficient of x to the 0 here? Write this one. What do you get? You get 1/2 plus. What is the first term? The first term is always f of 0, right? What is f of 0 here? 1. 1 plus sum n equal 1 to plus infinity minus 1 to the n. Now let's expand that. Right? Agree or not? This is the term for n equals 0. This is the term for n equal 1 plus infinity. Now, what happens to the constant terms? 1/2 plus 1/2, which is 1, right? Plus 1/2 sum n equal 1 to plus infinity minus 1 to the n 2 to the 2n x to the 2n over 2n factorial. Of course, here for all x and r, right? This is for any x and r, right? Because, right? Is it clear now? Is it clear? Any questions?
Why did we take the first term of?
I just want to regroup the first terms, right? So, write this down. You get 1, right? Then minus 1/2 times, what do you get here? 2 over 2 factorial goes to x squared. No, there's something wrong. So let's say 1 minus n equal 1, so you get x squared. The 2 goes away. That's weird. N equal 1, so you get 2, right? Oh, 2, so you get 4. 2, so you get 1 minus 4 over 2. Right? How did I know it's wrong? Can you tell me how did I know it's wrong? Oh, squared. No, why did I know that the 1/2 is wrong?
Is that for cosine?
That's for cosine, exactly. Right? You guys see this? You guys see this? Just expand it. I just want to regroup the x to the 0 term alone. And that's it. You see that? Or you agree with this one? Here, are we good? Until here, we're good? Now here, what is the minimal degree? No, the minimal degree is not 1. 2, right? Here, do you have any degree 0 term in this one? Do you have any degree 1 terms in this one? Here, degree 0, the degree 1, you have no degree 1 term, right? Is it clear or not? Is it clear? Why do I have no degree 1 term? Could you expect that? Could you expect that I have no degree 1 term in this Taylor series expansion? Why? Because cosine squared is an even function, so you have no odd terms in the power series expansion around 0. Right? Yes or no? Any questions on this? Yes, sir.
What is wrong if we didn't take the first term out?
No. No.
You
not wrong.
because you wanted to group it.
Exactly, I just wanted to group it. Okay. So if you stop here, that's fine. Okay? Just to make it look nicer, we just write it this way. Okay? Great, so what is the 8th derivative of f at 0? Do I need to differentiate 8 times? How do I look this up? I need to find the coefficient of what? Of x to the 8, very good. And then multiply it by 8 factorial. Very good. So what is the coefficient of x to the 8? How do I find this? I said n is equal to 4, very good. Everybody, is it clear why am I looking at n is equal to 4 or not? Any questions on this? Is it clear? I want the coefficient of x to the 8. For what value of n does the power of x equal 8? N is equal to 4. So what is the coefficient at n is equal to 4? Anyone can help me? So it's 1/2 times minus 1 to the 4. That's what? That's 2 times 4 factorial. Times what? Times what? Times what? I think that's it. Oh no, I forgot something. Times 2. 2 times 4 times 2 would be 8 times 8 factorial. So what do I get? Is that right? Times divided by 2. Let's do this. Okay? Did I make a mistake? N is equal to 4, that's good. 2 to the 8, 8 factor. Yeah. Is it clear or not, folks? Is it clear? Yes.
Should we ask the plus 1 at the end?
Where?
Sorry. Because there's a 1 plus and 1/2.
Here?
Yeah.
Oh, but 1 is the coefficient of x to the 0, right? You have x to the 0.
This one.
Yeah. So it's 1 times x to the 0.
Oh,
Okay? I mean, let's plug in n equals, yeah, that doesn't work because if n is equal to 0, you get 1 here. So you get 1 times. So that's, I cannot treat that. But anyway, is it clear or not? Is this clear? Everybody, is it clear? Should we do one more? Should we do one more? Let's try and do one more. I want to find something. Any questions on this? You will get tested on this. This is a question. You will have a question like that. Okay? Great. So let's continue. Any questions? Please don't hesitate to ask. Yes, sir.
So we put 2n is equal to 8 now?
N is equal to 4 here.
So 2n is equal to 8.
2n is equal to 8, exactly. Okay? You're looking for the coefficient. You're looking for the value of n for which this power is 8. You're looking for the coefficient of x to the 8, right? Are we good here or not? Yes. Well, if you can write it in one short sum, then yeah. Okay? But if you cannot, then that's fine. Okay? The most important thing is that I can read off your coefficients. Okay? This is fine. If you stopped here, it's not the end of the world, but you know, so yeah, okay? but you have to pay attention, right? If I ask you find the A derivative, you just have to not forget the 1/2, okay? Okay, great. Let's do. Any questions on this? Should we do one more? Should we do more questions like this? Let's do more questions like that. I don't want to chapter this in the book, but I'll pick questions from the book anyway. Okay. Let f of x be x to the cos x. Fine. Okay, who wants to suggest a number? Who wants to suggest a number? Okay, another number. 12, we have 12. Another one? 7. So find x7 of 0 and x12 of 0. It's 12 derivative. Let's do that. How do you do that? How do you do that? How do you start? What is this? fx is x. What is cos x equal to? It's equal to this, right? Right? For x and r. Agree? What is f12 of 0? What is f12 of 0? Immediately. The 12th derivative of at 0, what is it? Is 0. Why is it 0? Thank you. Why is it 0?
Even. It's an even number, and x can only have all.
The powers of x cannot be even, right? These powers cannot be even. So f12 of 0 is equal to 0. Did we expect this or not? Did you expect that? Why did we expect this? Cos x is odd, cos x is even, and x is odd. So when you multiply even times odd, what do you get? Odd, right? Okay, great. Now what is f7 of 0? So, who volunteers? What do I need to look for? What do I need to look for? Someone else? Yes? Very good. What is this number? 3, right? Yeah, very good. So 2n plus 1 is equal to 3. Very good. So for n equals 3, what is the coefficient? What is the coefficient? What do I need to do? I need to plug in n equals 3 in the coefficient, right? So this is just minus 1 cubed over 6 factorial. Did I forget something?
No.
Did I forget? What did I forget? The 7 factorial, right? So this is just minus 7. Right? 7 factorial divided by 6 factorial. Okay? Are we good here? Is it clear? Did I mess up something? Anything was messed up? No, I don't think so. Great. Okay. Do you want to do one more? Fine. Taylor series. Any volunteer? Any who wants to give me a strictly positive integer? A strictly positive integer. Who volunteers for a strictly positive integer? Yes, sir. 3? Around. Three to the x around a equals 0. That's difficult, right? Maybe difficult. But what if I transform my function? Guys, please. Yeah. How do I start? What if I write this as e to the x log 3? If I write this as e to the x log 3, isn't that correct? Isn't that right? Now I can use the power series of e to the x. This is just sum n equals 0 plus infinity log 3 times x to the n over n factorial. Okay? Is that clear? And you know we can simplify it. We can distribute the powers. Okay? Any questions? Any questions on this one? Is it clear? Everybody, any questions? That's good? Great. This is excellent. Okay. So now we'll use them to integrate. Now, if you remember from calculus 2, not every function was nicely integrable, right? So if I tell you to find an s derivative 0 to 1, let's say, cos x squared dx, how would you do that? You just couldn't. Right? Could you integrate cos x squared? Could you find that closed form from the antiderivative? You remember this or not? You cannot find this, right? It's a bit difficult. What do you need? What extra term could I add so that you can find an antiderivative for it? An x, right? X times cosine x squared, that you can integrate by the chain rule, right? By reversing the chain rule, right? What's an antiderivative for that? This is sine x squared over 2, right? Great. So now, let's do it using series. What is cos x squared? Yeah? So, right? So far so good? Now what can I do with the infinite, well, what can I do in this case with the infinite sum and the integral? I can switch them, right? You can switch the sum and the integral. Integral of a plus b is equal to integral of a plus integral of b. Right? So let's flip this. Switch, I mean it's not obvious why you can switch them, but we'll just assume it in this case. So x to the 2n, so what is that? It's x to the 4n over 2n factorial. Okay, how do you integrate this? Easy to integrate, right? So what's the integral of x 4n? This is x 4n plus 1 over 4n plus 1 from 1 to 0. So what do you get? You get just this. from 1 to 0. This is here, I don't know. Looks like a 2, it should be an n. Yeah. So what is this integral? So it's minus 1 to the n over 2n factorial. Integrate from 0 to 1 x to the 4n. What do you get? You get 1 over 4n plus 1. Right? Notice, does this series converge or not? Technically. Is it supposed to converge or not? It's supposed to converge because this thing is finite. Integral from 0 to 1 plus x squared is finite. So this series is supposed to converge. Now what test tells us that this converges in this case? The alternating series test, right? You see that? You can also see that it converges absolutely, right? Because, yeah. I think it converges absolutely, yeah. But the alternating series test tells you it converges. Right? 1 over 2n factorial divided by 1 over 2n factorial times 4n plus 1 goes to 0, and it's decreasing. And it's positive. So the alternating series test tells me that this converges. So if you want to estimate this integral, this series is a good estimation of it. Okay? And then from calculus 2, you know how to the remainder of alternating series, right? If you estimate up to order n, then the remainder is less or equal than the next term in absolute value, right? Have you seen this? You haven't seen this last term? Series, nothing with integrals. Okay. Well, sad, but you know what can I do? Anyway, well, I'll not spend time on this. Okay? I think you have a what, and in what work 3 I put a question on that, but yeah. Guess you'll have to figure it out. I'll remove it. I'll see. Okay? But the idea is that you can apply everything you know about series from calculus 2. Right? That the remainder, hey guys, that the remainder is the error term. Have you seen that the sum of the series minus the nth partial sum is less or equal than the n plus 1 term here in absolute value? No? Okay, great. So we'll skip on that. That's okay. Not the end of the world. Again, it's calc 2, so I mean I've repeated most of it. That you can easily convince well. But I mean, if you're going to estimate this integral, just pick a high number, and these are easy to compute, relatively easy, right? Okay, great. Okay, so I think that's it for a series. We can do more examples. I'll do 1 or 2 more examples. Any questions on this? Guys, okay, please. Any questions on this? Okay, maybe we can do 1 more example. I think I've written. I have 1 more. Let's see. Integrate from 0 to 1/2 x cubed. Is it x cubed? Let me check. Just let me check what I have. I mean, it doesn't matter. X cubed or 10x dx. I think I gave this in a calc 2 final. That's why I have it. So. How do you integrate that? What do you use? What do you use?
Power series for arc 10.
Power series for arc 10, right? I don't know if you can do it by parts actually, but I don't think so. Okay, I don't think you can do it by parts. Because, I mean, yeah. And arc 10 of 1/2, you may, yeah, if you need that. But anyway. So what is the power series for arc 10? You forgot how to do it. How do you rewrite it?
You integrate the geometric series and set it like the other.
Exactly. So I integrate 1 over 1 plus x squared, which is just this sum, right? Integrate both sides. Integrate both sides. What do you get? Minus 1 to the n, so you get x cubed. X2, right? Is that right? Is that what you had before? So what do you get? Could you do it just by looking at it, or not? So let's do it. This is sum n equals 0 to plus infinity, so the n stays over 2n plus 1. Okay, so I get x to the 2n plus 4, right, by just integrating this. So when I integrate this, I get x to the 2n plus 5. Let's check something. And then I have to plug in the values of x to the 2n plus 5 from 1/2 to 0. Okay? This is how you do it. Just integrate. Calc 2 integrate. Okay? Fundamental theorem of calculus, that's what you get. Okay, great. Is it clear or not? Yeah, just straightforward integration, okay? Yeah? Straightforward integration, that's what you get. Okay, now we did an example last time by looking at the limits, right? Finding the limits using series. So let's do a few more like this. Let's see. What do you want? You want something more difficult, easy? We start with something easy and end up with something difficult. Yep, let's do it. Usually these are a bit, these are not hard yet. Questions? No? Are we good? So evaluate this limit without using L'Hopital's rule, of course. Okay, using L'Hopital's rule is easy, right? 0 over 0, you differentiate, you get 1 minus 1 over 1, oh, how is it? 1 minus 1 over 1 plus x divided by 2x, right? Again, you can put the x upstairs, you can maybe put the x, no, well, 0 over 0 still. L'Hopital's rule again, right? X becomes 1, and minus 1 over 1 plus x, what's the derivative of that? It's, what's the derivative of minus 1 over 1 plus x? So it's 1 over 1 plus x squared, right? 1 over 1 plus x, the derivative of that is minus 1 over, yeah. So the limit should be 1, I think. 1 or minus 1. Okay? In any case, how to do this with series?
Can you put the series for ln 1 plus x?
Exactly, so I put the series for ln 1 plus x. What is the series for ln 1 plus x? Again, what is it equal to? I mean here, actually this is because x belongs to minus 1, 1. Of course, the arctan series may converge. A series may converge at the endpoint. Minus 1 at 1, but I don't need that. Okay, so by staying safe, by opening the intervals, I stay safe. Okay, because I don't need the convergence at -1 or 1. Anyways, so what is ln 1 plus x? Who can help me? Yes, sir. Sure? Okay, so let's rederive it. Very good. Let's rederive it. So it's the integral of what? Right? Dx, and then you have to add a constant c, right? Okay, so let's integrate that. So what do you get? You get sum n equals 0 to plus infinity minus 1 to the n, x to the n plus 1 over n plus 1. Right? That's what you get, no? Yes or no? Are we good? Now this is ln 1 plus x, and I have a constant c here. How do I find the value of c? What number could I plug in? 0. Ln 1 plus 0 is ln 1, which is 0. 0 plus c, so c is equal to 0. Okay? Very good. So what is, let's write it here. So ln 1 plus x. What's the first term? It's minus x, right? For n equals 0, x, right? Minus x. What's the second term? So n is equal to 1, right?